Hello everyone and welcome back to Python lessons on Codecademy. So today we're continuing on with the topic on classes. So our first lesson is more on init and self. Let's just read through because this is a complicated topic, so I think that I will just be reading through the instructions as well as the descriptions. Now that you're starting to understand how classes and objects work, it's worth delving a bit more into init and self. They can be confusing. Okay, and they are actually confusing even to me. As mentioned, you can think of init as the method that boots up a class instance object. The init bit is short for initialize. Okay, so I will be calling it initialize because init kind of annoys me. The first argument initialize gets is used to refer to the instance object, and by convention that argument is called self. If you add additional arguments, for instance a name, age for your animal, setting each of those equal to self.name and self.age in the body of initialize will make it so that when you create an instance object of your animal class, you need to give each instance a name and an age, and those will be associated with the particular instance you create. But sometimes you might not want to pass an argument, so instead of doing that, you can give it a default thing, which it can be. So you can give it a default age of 5 if no age is entered. I don't remember how to do that, but I know that that's a thing that classes can do. For example, if you take the range function, I know it's a function, but we can compare it easily. If you don't give it the if you don't give it the start or the step, it's going to take step default as 0 and start default as 0 as well. Or yeah, as 0. But if you do give it those two arguments to it, then it's going to start at where you've told it and step by how much you've told it. It works similar to classes, but I think that that's a bit more advanced, and hopefully it's also covered. Just a preview of what we will be learning. So check out the examples in the editor. See how initialize puts up each object to expect a name and an age, then uses self.name and self.age to assign those names and ages to each object. A third attribute is hungry to initialize, and click save and submit add a third attribute and click save and submit code to see the results. So we need to add is hungry. So we need to put that there and initialize it to equals that, and we need to self.is hungry. There we go, and let's save and submit and see if that works. So is hungry, some of them might be hungry, so true. Jeffrey is hungry, Bruce isn't hungry, Chad is hungry. Doesn't help us in anything right now, but hopefully it does later on, so let's move on. Class scope. Another important aspect of Python classes is scope. I have no idea what that is. The scope of a variable is the context in which it's visible to the program. Okay? It may surprise you to learn that not all variables are accessible to all parts of a Python program at all times. When dealing with classes, you can have variables that are available everywhere, global variables, variables that are only available to members of a certain class, member variables, and variables that are only available to particular instances of a class, instant variables. Okay, that makes sense. The same goes for functions. Some are available everywhere, some are only available to members of a certain class, and still others are only available to particular instance objects. Check out the code in the editor. Note that each individual animal gets its own name and age, since they're all initialized individually, but they all have access to the member variable is alive, since they're all members of the animal class. Click save and submit code to see the output. Okay. So, is alive, all of them are alive. Hopefully it covers it in a bit more detail. So from what I can understand now is in a class you can have some variables which are only accessible by the class, others which are accessible to to everything, and some which are accessible only to a function in the class. Or that's what I understand, and yeah. So if you have questions about this, do ask in the comments. I will try to answer them after I've understood it in my own time. But for now, hopefully it goes into a bit more detail. So let's move on. A methodical approach. When a class has its own functions, those functions are called methods. You've already been seen one such method, initialize, but you can also define your own methods. Add a method description to your animal class. Using two separate print statements, it should print out the name and age of the animal it's called on. Then create an instance of animal hippo with whatever name and age you like, and call its description method. So I guess we're defining our own function kind of things. So we need to define name, and do we put self in it? I don't remember, so let's actually get a hint before I get stuck on this. Okay, so this, yes, we do need self as an argument in there. And then we have print self dot, it wants us to print the name, and then it wants us, oops, wait, do we need to, oh, this is description. Okay, so we need to print the name and print the age. Okay, so if we've done that, now we need to create a hippo, and I will just call it hippo animal, and pass the name, let's call it Bob, because I can't think of anything more creative, and age of 7. Does it need to be a string? I will not make it a string, because I think it's better to keep it as an integer. And then we need to set, do we just need to make a hippo? Yep, just a hippo. So let's, and then we need to print the description of our hippo. So hippo.description, oops, dot description. And is that it? I think it is. I hope so. Anyway, yes, it is. So we've made our own function in the class, which when it's called through our class, it prints the description of that instance of the object or the class. So it prints Bob, and then it prints a 7. We could have made it something more fancy, like my name is Bob and I am age 7, but this was the simplest way, and if we need to use this again, I will make it like that so that it's less annoying. For now, let's just move on. They're multiplying. A class can have any number of member variables. Yes, just like you can have as many strings as you want, you can have as many animals as you want, or as many integers as you want. Yeah. These are variables that are available to all members of a class. Okay, in the example above, we create two instances of an animal. So we create a cat and a hippo. The hippo's name is Jake and is aged 12. The cat's name is Boots and is named 13. Then we print out, oops, let's scroll like this. Then we print out true. The default value stored in hippos is a live member variable. Okay, so hippo is alive. I guess it is alive. Next, we set that to false and print out to make sure. Oh, we killed the hippo. Okay, and then finally print out true. The value stored in cats is a live member variable. We only change the variable in hippo, not cat, because each instance of the object has different variables, if you would. And Jake, the hippo has a name of Jake, whereas cat has the name of Boots, and those will always stay that way. Hippo is never going to be called Boots, or hippo is never going to have the age of 3, unless you change it manually through the program, or you've made it after a year to change its age. Yeah, so let's add another member variable to animal. After line 3, add, so line 3 is there. Add a second member variable called health that contains the string good. So, okay, health equals good. Is this what it means? I have no idea. Oh, no, that's not what it means. Okay, so we need to make that there. With okay, then create two new animals, sloth and ocelot. So let's do that with give them whatever names and ages you like. So what to call it? I don't know. We already have Bob. We can call it Dan. And age, let's make it an old sloth, 90 years old. Then Ocelot equals, make it animal class, and let's call it, I don't know, Joy. Why not? That's what my aunt's cat was called. And age, I don't know, why not? Let's just set it to 9. So then we do that. And step 3, finally on 3 separate lines, print out the health of your hippo, sloth, and ocelot. So, okay. We just, no, I think oh, okay, good, never mind. Dot, we need to print out the health. So we'll just do this. Oops, nope, not that, that. So I can easily use just the name and paste and print. We've done the ocelot, now we need to do the sloth. Let's see if that works. Yes, it works. So all of them are in good health. So let's move on. Oh, actually, let's go back and explain it. I think that would be helpful, wouldn't it? So here we're initializing new values to, new variables in that class, but all of those will be different for each class. You can change them, and if you change only one of them, it's not going to change for all of them. So if you change hippo is alive to false, as we saw here, sloth and ocelot are still going to stay as true, because you haven't changed their value of is alive. Then if you change health of, say, ocelot to bad, only ocelot is going to have bad health, whereas sloth and hippo are still going to have good health. So hopefully that explains it. If it doesn't, then please do ask in the comments. It's not all animals and fruits. Okay. Classes like animal and fruit make it easy to understand the concepts of classes and instances, but you probably won't see many zebras or lemons in real-world programs. Probably not, and it makes sense why. However, classes and objects are often used to model real-world objects. The code in the editor is more realistic demonstration of the kind of classes and objects you might find in commercial software. Here we have a basic shopping cart class for creating shopping cart objects for website customers. Though basic, it's similar to what you'd see in a real program. Create an instance of shopping cart called myCart. Initialize it with any values you like, then use the addItem method to add an item to your cart. So, okay, let's just follow the steps and then see if I can explain what the class does. Shopping cart, so I will just call it, okay, so we are told what to call it. We need to call it myCart. And an instance of shopping cart, and we need, what does it need? It needs a customer name. Okay, let's put my name. And if you're following me on Twitter, you would know that that's my name. If you didn't know that that's my name, then go and follow me on Twitter. Thank you. Okay, so now we need to add item to that cart. So myCart, and how does add item work? I have no idea. So product and price. Let's add, I don't know, StarCraft. I know I have it. I will just add it on. As well as the price. I don't know, what was the price? I think it was like, I'm really not sure. I'm just gonna put 20. And actually, that's probably going to be a number, so I'm going to put 20 like that. So that's not right. Add, oh, underscore item. Is that going to work? Yes, so it says StarCraft added. And okay, so let's see what this function actually does, and then we can end the lesson off. So the function creates shopping cart objects for users of our fine website. Don't know which fine website, probably Amazon, eBay, Blizzard, and the similar, but okay, so let's see. items in cart at first is an empty dictionary. Okay, so I'm guessing the key is the name, so StarCraft, and the value is 20 in our object here. And then we define an initializer which sets the name to the customer name, so we are given our own name. And then we need to define a new function, add item, to add items to our items in cart. If the product isn't in the cart, then we add it, as we can see here. Or at least that's what I understand. Okay, let's self.items in cart product equals price. Well, actually, we don't need to really understand this, but let's see. Self.items, items in cart. What is items in cart? Where do we create items in cart? Okay, so that's items in cart. And the product is the equals price, and then we tell the user that their item has been successfully added to their cart. Otherwise, if it's already added, so if the product is in the cart, then it tells the user that it already is in their cart. Then we make another function, remove item, which I'm guessing just removes that item from the cart, and self.items in cart or products, and we delete that, so using del, and say the name of the product has been removed. I don't understand how this would really... Oh, we pass the argument product, and that's why it works. Okay, so that makes sense. Otherwise, if it's not in that dictionary, then it's printed as that the item is not in the cart. So hopefully that makes sense. If you have any questions, please do ask in the comments. I will do my best to explain, and as soon as possible. So until next time, please like, share, and subscribe. If you liked the video, click the dislike button if you didn't like the video, and tell me why you didn't like the video, so that I can improve for next time. Until that next time though, thanks for watching, and goodbye.